we came here to talk a little bit about movement and what we're building. Just wanted to intro you about movement. So we're doing move chains. We're doing an ecosystem of chains based on an Avalanche subnet, and then using a shared sequencer to deploy layer 2s. The very first one is a ZK move that settles on ETH and uses Celestia as DA. I'm Lucas. I'm the dev role for our movement. And this is Andy Golay, our solutions engineer, who will help me here with SUI, since he knows a lot more about that. Can you guys see it properly? There we go. So the plan here is to basically go through a deployment of a full stack chat dApp on both Aptos, the move that Aptos uses, so we usually call Aptos move, and also a SUI move module. And we'll do the deployment both on our networks that are currently live on DevNet that anyone can try out by just pulling our movement CLI, and then you can basically make the deployment. And the idea here is that we wanted to have a very simple dApp to deploy, create a front end, and let anyone play around and maybe introduce some changes, introduce some new features either to the front end or to the modules, and tinker a little bit with what move is. And this is basically our approach to building. We're trying to be as modular as possible, and we really want developers to try out Move as a language, a safer language for the wider blockchain ecosystem. And it's once you pick it up, it ends up being quite intuitive on how to work with it. So yeah, it should be pretty simple. So yeah, should we go through the deployment already? Yeah. Cool. So let's just start with the deployment on Aptos.
Are you going to show the finished apps first?
Oh yeah, yeah, nice. Good reminder. So we have here this. So this should be the SUI version of the chat. Basically, we have anyone can connect and send a message to this module and this chat that is specifically deployed to this module. We'll start off with the Aptos version. It's pretty much the same thing. It's just a different connector, and it's using Aptos. The frameworks are a little bit different. Move is a language that did adapt according to either Aptos or SUI, and they took a very different approach on how to use the language. But you see a little bit more about that. So let's start off with Aptos. So basically it all starts with an address, and on that address you can access a certain module by its name. So here's the chat address. And then you're accessing the chat. To use libraries, you use this standard, very similar to Rust. So any Rust developers should be able to straight up read this pretty easily. And then you have, very similar to Solidity, you set up your const, and then you work with structs. We have a chat room that will store the messages and also some count of how many messages have been sent, and a struct for messages. You can see that you have some abilities here. This is very specific to Move, and it helps with security. And here we are using a message that can be a key. It can also be stored, and it can be copied. Nice, thank you Google. And it's storing basically who sent it, what the text is, the time it was sent, if you're responding to a certain message or a certain address, and some metadata. And then you have a init module, which is basically this function will run during deployment, or in Aptos, and so you usually call it publishing the module. And then you have a create chat function, a get messages function that is view only, and then some post internal. It should be, if you're aware of how Solidity works, you have internal functions, and then you're just naming it as internal, and this is the main function that will actually perform the message being posted to chat rooms, and then some access functions that are entry. Entry functions are the functions that any address can actually access and interact with certain modules, and this introduces some security features to Aptos. So I just wanted to go through it really quickly and do a deployment. You should actually start off with by installing our CLI. It's a very simple command, and then you can go through the script. Let me just copy this a little bit simpler. Oh yeah, I wanted to touch on this really quickly on how to set up your private keys and stuff. I already have it set up here. Once you run this command movement, Aptos move init, you are creating a private key locally. This is already set up, but I'll just delete this and show you guys what it looks like. Movement, Aptos move init. Oh, init. Sorry. I can pick the definite here. It will give me a private key. It just created an account for me, and I'm ready. I'm basically set up. I can go back here, and I'll have my account. This should be the public key, and then these are the URLs that you use to basically as an RPC to movement. I'm just gonna switch this up for standardized URLs. So what we do here is to build any RPC on movement is you access the chain, the network, and then the language. Okay, cool. So we made the deployment. We have we have the module deployed on this address. I'll access the front end now. And this should be running the previous one that I deployed. And it has the older address very likely. Oh, this is sweet. Front end components chat. Okay, here's the address. This is the older one. Let me go to, oh shit. No, don't open up. Get up. Okay. Localhost. Okay, here's the older one. I already have my wallet connected. I'm just gonna send a message to the older one. Transact. And the message should pop up here. Hello. Okay. Now we're gonna change the address here to the new one. And this module should be empty. Okay, yeah, now we have it empty. So let's change it to, hello, Avalanche. No, doesn't exist. What's up? Let me see if config is correct. This should. Hmm. What's the issue here? This is deploying to correctly. This was the address. Oh shit! I forgot to actually deploy. Should have told me. Moving out to move, publish. Name addresses. So how you do it, how you access the addresses that you're working with is basically you call it with a name address flags, and then we are doing the chat address, which should be our module being deployed, and then you call it default, and it's basically you're deploying to the address that you're at. This is very interesting because you can actually have multiple modules to the same address and something specific to move, and it ends up being pretty cool. So now we should go through deployment. I do want to spend some money here, and I'm okay. Okay, now we should be okay. Let's see. Of course. Okay, cool. Now I don't have an error. Hello, Avalanche. Approved transaction. And here we have it. And now it's stored on the chat room. And yeah, so it's a pretty simple process. You push this anywhere, and here you go. You have a live chat with your friends on the blockchain. And now I'll let Andy present the SUI version.
All right. Yeah, so the SUI version will be a little different, but I think you'll see it looks very similar. The SUI move versus Aptos move. I guess we start off just looking at the module. So, okay, so here's the SUI module. I want to pull up the Aptos one as well, just to be able to compare and contrast. Oh, just
you want to pull it?
Yeah.
Oh, okay.
So you'll notice on the side here, the with the Aptos app, it's using everything. All these imports are from the standard library on the Aptos side. So that kind of speaks to the ethos on Aptos, which is kind of just using move as it is and not really trying to make it into a different language or really extend it in ways that sort of redefine the language. But on the SUI side, there's you have this SUI object, SUI transfer, SUI transaction context, SUI clock, which is a different way of getting a timestamp from the network. So all of these, they kind of they highlight SUI's object-oriented paradigm versus Aptos has more of an account-oriented and resource-oriented kind of paradigm. Like even just deploying with Aptos there onto movement, you had this named addresses flag, and so it's more like you're deploying this module to an address or to an account on Aptos, versus with SUI, which when we get to the deployment, you'll see it's more like you'll generate a package with a package ID, which is its object ID, and then a chat room with its own object ID. So it's sort of decoupled from the address that you're deploying from in a certain sense. So as far as the actual the differences, we have like for example, our structs. Pretty much the chat room struct looks about the same, except here on SWE you have this ID, which is it's essentially an address that's just wrapped in this concept of an object ID. So it actually an ID actually is an address, but SWE, they wanted this object-oriented sort of paradigm. So that's why every object has an ID there on SWE, but otherwise you see it's the same messages as a vector of these message custom types. So that's what a struct is. It's a custom type that you can define yourself. And same thing with the message struct. You see they're the exact same between Aptos and SWE, except SWE you have this ID, which is it has the universal ID, which is just a unique identifier for each object. All right, so another thing that's similar but slightly different in the syntax is, so a init module is run every time if you publish the package containing this module on Aptos, it runs a init module as a sort of a one-off, one-time function, and on SWE it's a init. So same basic idea though. You have you create a new object, a new chat room object specifically, and they do that through this object new, and then the reason why they pass in CTX, which is a mutable reference to our transaction context, is because to get a new object ID, they use randomly generate it from some properties of the transaction context, like just some specific things related to like exactly when that transaction was submitted to the blockchain. So and then in Aptos, you move that chat room object to an account using that sort of native move to move function. But on SWE, they do a transfer share object. And the reason why, so SWE has this concept called a shared object, which is like, it's an object that anyone can access. So versus an owned object where it's like, this is just, this chat room object is just going to be going to that account, and to access it, you need to borrow, values in the fields in that custom type. But with a shared object, it's just anyone can, if there's a function which like the post function, which we have for this entry function post, to post a message, just anyone can do it. All you need to do is pass in the chat room, a mutable reference to a chat room. So basically, pushing in the. I'll show you on the front end how you do that, but it basically you feed it in the chat room's object ID, and then I'll pull up the post function from Aptos side so you can see the difference in the timestamp, how they do that, run SWE versus Aptos.
Timestamp looks like that here.
Let's see. Okay. Yeah. So on both of these modules on SWE and Aptos, we have two different post versions. So we have post and post with ref. And just a little teaser, that challenge we'll give you at the end of this is to see if you can maybe spice up the app and extend it utilizing post with ref, because basically, you could make it so people can reply to each other, or have posts linked to each other in that kind of a way. But each of those are entry functions, meaning that a wallet can interact with those functions. Someone can just use their wallet to call these functions and as an entry point to the module. But then what they do is they call post internal in both of these. So that's where kind of you see the rubber meet the road for the actual posting. So just comparing the post internal functions, we have on the AppDOS side, you don't pass in the clock. What you do is you just get a timestamp. There's just kind of like a native. I think was that from standard library?
From standard.
Yeah, so that's from the standard move library. So they have the timestamp just sort of done in that sort of direct kind of way, which I think on Aptos that comes from a validator. It gives them the timestamp, if I'm not.
From the framework.
Okay, yeah. So, but on SwiMove, it's on Swi we're gonna pass in a
Clock object.
yeah, the clock object, which. Oh yeah. Sorry, I'm like looking over there. Yeah. So what Swi does with that, they have an on-chain clock which they keep at. It has an object ID of 0x6. So it's just they keep it there at that object ID. It's an instance of their clock which updates every checkpoint, which is like once every second. They update the clock's timestamp value in milliseconds, and so any function where you want to have a timestamp, you end up passing in a reference to that clock object, and it's made easier with the front end SDKs. You could just basically pass in that object ID, the 0x6, which I'll show you. And that's basically it. So instead of needing to borrow, like in an Aptos, you do borrow global, mute, chat room, and then chat room there, that's the address, the lowercase chat _ room. That's the Aptos, address on Movement Network where this chat room lives, that owns this chat room. But on SwiMove, you just pass in a mutable reference to that chat room. If you want to do something like here, we're accessing the messages, and then you just, you can push your message onto into that messages vector. So you see it's very similar, just some, in the overall structure, but just slightly different syntax. Deploying, publishing your module on Swi is also kind of similar. So let me just cd into Swi. Let's see.
Seems like it.
Where's your slash?
Oh. Do you want to go to front end?
No, sources.
Oh, wait. I already accessed it.
Oh, okay. CD. Okay, sources. Okay, so got my one-handed typing going here.
Let me try. Do you want to show the sources?
No, just do CD sources because it just needs to deploy from there. Yeah. Okay, so we can do Swi.
Wait.
Oh yeah.
Let me help you.
Okay.
Okay,
so
was it client publish?
And then gas budget.
It should be then ignore.
Skip dependency verification.
Skip.
Maybe say like 5 with like 7 zeros.
Oh.
Sui keeps increasing their gas budget. It used to be like 10,000 mist, which is like a unit of Sui is like a Sui coin is 1 billion mist units, kind of like Satoshis with Bitcoin. And yeah, the price it used to be like 10,000. Now it's something like a few million mist. So you'll see this digest come up, this summary when you publish. So if you wanna scroll down, the main things we need are this. So the created object. Okay, so published object. This is our package ID versus created objects. You scroll up a little to this one, the shared object. Created objects are more like just regular objects on chain that aren't packages. So when they call it publishing, just when it's a package. And so to get our chat room object, we look for the shared object, because we know from our init function that when we publish our package, that init function is going to run. It's going to create the shared chat room object. So those are our objects. So I can show you where we plug that in to the front end. So basically, you want to.
A second.
All right, so this is our front end for Sui, and these are our old chat room IDs. And if you want to, so similarly, like with the Aptos one, how we had this live. You want to show the Sui one, the Sui
one.
app live, and just show like, and then maybe we switch these out.
The Aptos front end, sure.
Yeah, the Sui front end. Like the actual, like the live.
Oh, okay. Let me pull up this one as well. We'll have
It's already running, right?
Yeah.
Like Sui chat.
What?
Isn't it already running?
That's the Aptos. Oh, okay. Give me this one.
Yeah, so we have this, so we already have these, messages populated here. So this is a front end that's connected to, a package ID for calling the post, the post function, and then also passing in the chat room object, mutable reference. So yeah, so what we can do is we can go to our code in our front end, and so our package ID, we can replace that with. So you see how in our chat, so we have a chat component, and then we're gonna just hard code our chat package ID and a chat room ID. Usually I put it off in like a constants.ts file or something, but we're just kind of, we're just laying it all out here for you. And then the chat room ID. And once we replace those and redeploy our front end, then that front end will be configured to the new chat room that we just published. And the chat room object that we shared. So let's see. Once we see that in action, we'll connect our wallet, and looks like we got a brand new chat. So we also did something where we have it like if the message is from you saw it's like the text is on the right, and see right there, and so All right, what do you think's good next? Should I go through the Sui front end, or actually, you didn't go through the AppDOS front end in much detail yet.
Yeah.
So you want to do that, and then I'll go through
Yeah.
the Sui front end.
Yeah, sure.
All right, cool. So now Lucas is going to go. We'll go into the front ends in detail, so you can compare and contrast how those look on the AppDOS versus Sui dApps.
Okay, cool. So, I'll just open this one specifically. Aptos generally has a very similar dev experience compared to Solidity. You see some similar nomenclatures across the dApp. There are a few libraries out there that let you use hooks. It's still very much underdeveloped, but it's mostly because Move is a new language, and specifically it needs more tooling, and it's something that we're looking for people to help with. But essentially what you're doing is you're instantiating a client here with an Aptos object, and then you push in some configs, and then you have the RPC that you use to access that network, and then you see an ABI here which basically lets you interface with the dApp. Aptos also includes the address of the module in the ABI, which is interesting. And then you're instantiating some hooks. You get the messages. You use a use effect to constantly fetch the messages, a function to post a message. You build it with a payload, and this is specific. It shouldn't be specific to Aptos or Sui, but it's something that hasn't been abstracted yet on the tooling side. And then you go through submitting the transaction, and then you should be good. And then we build a very simple front end here. So yeah, in terms of development, it's quite similar to how you develop a dApp in Solidity. So maybe it's a good touch point for anyone coming from Solidity. And Sui, on the other hand, has a few different, because of the object-centric network. Essentially, you're fetching some data from the chat room ID, and that brings in a different way of fetching data on-chain. We did include on the Sui chat module, we did include a function to fetch the messages, which is very similar in Aptos, but usually you do something else. And I'll let Andy show you guys how to do it.
Yeah, it's mainly a question of like whether you want to deal with the complexity of an object on the front end or not. Like the way Lucas did the ABI with accessing the Aptos data. It was like it's sort of like the complexity of the parsing the object is handled more from the function on chain. But for Sui, so you could do something like that. Like I had a function just to get the messages, but I tend to do this like query client type of thing. So our page, just the way the general page is set up, you'll notice this like triple wrapped type of body of the return here. So you have the wallet provider, which lets us connect a wallet to the web app there, and then that's wrapped in the Sui client provider, which gives us abilities to interact with the Sui blockchain. And then query client provider is just more like a React query toolkit for being able to fetch and cache and update data on the React front end. So the main action happens for the chat side in the chat module.
Oh, that's the.
Let's see, that's the Aptos one. So here's the SWE one. And so you have so you have your chat room ID and then the chat package ID, and we have our message history, which is essentially that the set of messages that's displayed in the app, and then you have message, which is like our current message that we're typing into the chat box, and we're using use state to update those states.
Maybe touch on the get messages.
Yeah. So with get messages, okay. So so what we're doing is, so we have this data, this data value that is being defined by use SWE client query, which is from Mistin's dApp kit. So that's the main toolkit we're using is Mistin dApp kit for specifically querying and then also signing and executing transactions. But we're getting the transaction block type from the SWE JS SDK under transactions. And so what you do is, so data is being defined as you do a SWE client query with the get object method. So this method, you
were talking.
Okay, yeah. So that method is going to be get object. There's a bunch of different methods you can use for querying the chain. And then it's taking in chat room ID right there for the object ID that it's looking for. Okay, so data is going to be the data that's associated with that on-chain object ID once the query returns its response. So so you go so the way the data is, it's like data.content, and then you can get information about the content. So we're checking to see if this object is actually a move object. If it's not, then we'll just return null for get messages. But if it is a move object, then we return fields of that object, specifically the messages field, as a vector of messages or an array of messages. And so then we await refetch, which is just kind of like redoing the query, like fetching it to the front end. And then we do a little scrolling magic to make sure that the messages don't just get lost, don't just get buried behind the text input prompt. And so basically the long and short of it is we do set history with the messages vector that's a field of the chat room object. And so we set history with those messages, and then the history is just...
And then good to go.
And go to what?
No, then you're good to go.
Yeah, and then we're good to go. I mean, it's the same thing. Like you can study how we parsed the history and put it out, but basically it's just map. We do like history dot map message an index, and you have this map is how we actually populate the front end with with the messages in the in order with this map that we do here. Anything I missed about? Oh, the transaction block, right? Okay, for posting, all right. So we have this function post message, which is called
On when you send a
on
message.
submitting the form where we input our messages. Same thing, the button there on click, the send button, that triggers, that calls post message. So what that does is, all right, so we define a transaction block, a new transaction block, which is like, it's just a transaction. A transaction block is really just a transaction on Sui. I think they call it that because Sui does not have a typical traditional concept of blocks. It's not exactly a blockchain in the sense of like, a linearly ordered sequence of blocks. It's a DAG, a directional acyclic graph. So it's like with inputs and outputs that connect. In sort of a hybrid UTXO account model. So I think they call it transaction blocks sort of to give themselves a feeling of having blocks, frankly. Because you can think of a transaction block, I think of it like a Solana transaction, if you're familiar with those. It has a bunch of instructions, and if one of them fails, they all fail. It's just an atomic attempt at doing a transaction. So really a transaction block, you can think of it as just a transaction, and it takes in arguments and also has and then commands. So like here, we're just doing in this post message, we're just doing one command, which is a move call. There's a very limited number of commands transaction blocks can have. Like, I think there's only 9 of them, like transfer an object and publish something, But here we're doing a move call, which means we're calling a move function on Sui move. The target is the actual function, so that's where we're using our chat package ID, which we put in. We hard coded right here. Into our chat component, and we're calling the module chat and its function post, and so we're calling that function post in the chat module. What was that?
10 minutes.
10 minutes? Okay. So
3 minutes. 3 minutes.
Oh, 3 minutes. Okay, let's wrap it up. So then the arguments, you'll notice they're the same. If you go in and look at the move module, they're the same arguments. There's the message. There's the I put so that's the text. This is just an empty string here. That's the metadata. So if you wanted to, you could add metadata, and then you go TSP object, the chat room ID. That's the next argument, and then this 0x6 is our reference to the instance of the clock object who has ID 0x6. So you see the front end is kind of handling that for us. Like, we don't have to sit there say like we're passing a reference to this object. You can just kind of get away with going TX pure. And yeah, so a little bit more object oriented, but sort of very similar as on the Aptos side.
Okay, cool. So I'd say I'd just like to wrap up a little bit. This is available on our GitHub for anyone who would like to try it out. You should be able to see it on github.com, Movement Labs XYZ, Movement dApp Workshop. We had as well, I just closed it. 1 second. Here we go. just like to open this up. So if you'd like to join us and try out one of our programs, which is the Movement Open Builders program, we'd love to support any developer who'd like to try Move and start building something. We'd love to make the connections with whoever you need, and essentially we're looking for developers who are pursuing a career, and yeah, it's a very interesting language to try. It's novel, it's fun enough to test things out, and in general we'd like to invite developers to try and PR or bring some new solutions to the current repository that we have live. We did include a few bugs in the modules that should get you to understand a little bit more about Move once you get to research it. So please tinker with it, try to break it or make it work even better than it currently is. We'd love to see what you can accomplish with it. So yeah, I believe that should be it.